electric circuit and its components. Okay. Now, what is an electric circuit? A closed conducting path through which electric current can flow continuously. Okay. In a very simple way to understand electric circuit, according to this definition, a closed conducting path. So path means, see, the road, the path. For example, a broken TV and all, and a toy. Sometimes you see inside it's a small circuits which has some lines which are drawing. So if you look at that lines, it just look like a road. Okay. So in the map, if you look it very closely, the map has a number of lines which are drawing. Okay. Those number of lines which are drawing are the path, the road. Okay. Same in a broken circuit. See, in a circuit, if you observe it very closely, you will see number of lines. And those lines are the conducting wires which has been placed there. It looks like exactly like the map of the earth. So those are the paths where the electric current can flow. So it is a closed conducting path through which the electric current can flow continuously. Okay. The basic components, a very simple components of a simple circuit is a bulb, a wire, a battery and a switch. So these are the components of a simple circuit. For example, if I want to make a circuit of this with these components, it will be something like this. Let's say this is a bulb. I'm going to draw exactly the bulb. Okay. Now, let's say this is the bulb, and this is the wire which is connected to the bulb, and we have bulb, we have wire. Now we need the battery. Okay. And let's say this is our battery. This is a battery. This is positive terminal. This is negative terminal. Now it is connected here. Our battery diagram is finished. A battery is a source of current. Means a battery provides current. Okay. So it's a source which provides current. Then we need a switch. So this is a kind of switch we have. This is closed switch. We have two types of switch, closed and open switch. Okay. Now our diagram is complete. Okay. So the wire is connected with the battery and the switch and the bulb, and the bulb will glow now. Okay. So once the switch is closed, the electric current start flowing in this bulb. Okay. And then current flows from this direction, positive terminal, goes like that current. Once the switch is on, when switch is closed, it reached the bulb and the filament of the bulb got heated up, and that heat converts the heat energy of the electric current into light energy and then gives out light. Okay, it goes like that. So our simple circuit diagram is finished. This is simple circuit. Now there are more circuits which are not simple as like this. Okay, there are different type of circuits you will see in the different load. Load means the device which you use with the use of electricity. Fridge, refrigerator, fridge, TV, and many other things are there. Computer. Okay. So those are called loads which consume the electricity. Okay. Without the electricity, they will not work. So in every loads, if you see inside, there are so many circuits, and the circuits are not simple as like this. They are the complex circuit. Many small parts are connected to it. So if you are going to draw a diagram to make a circuit of any device, are you going to draw exactly like this? A battery, a bulb, a condenser, a resistance is there, okay, and many things are there, okay, diode are there. Are you going to draw the exact diagram? No, it's very difficult, not possible. You will not even be able to use this entire board to draw the circuit of that load. So now it's become more complex. So to reduce this complexity or difficulty in drawing the circuit, we have symbols. Okay, the symbols which we use for drawing a diagram of a circuit, okay, that one, symbols will represent the elements which you are going to use. For example, if you are going to use this bulb in the diagram of a circuit, you will not draw exactly the bulb. You will use a symbol instead of this bulb. So bulb is represented by this symbol like this. A battery and the switch, okay, the switch doesn't look exactly like this, okay, that's different. So this is a symbol of a switch. This is a symbol of a switch. A wire is represented by just one single line, okay. A battery is represented by like this, okay, plus and then minus this side like this, okay. So now let's revise one more time before we move forward. So what is a electric circuit? It is nothing, just a path, a way through which the electric current flow continuously, okay, and it is a conducting path. And we know that the basic components, the simple circuit diagram has these components: bulb, wire, battery, switch. And we do not draw exactly the same bulb, we use symbol. Now let's learn about the more symbols of our electric circuit. Now these are some of the components of our electric circuit, okay. We'll study about the symbols and the functions. The number one, we have electric cell, okay. A cell is represented by this symbol, okay. And what is the function of this cell? It generates potential difference across the end of a conductor, okay. Number two, we have battery or cell. Cell or battery. So a battery is a component of two or more cells. Okay, the torchlight which you use, the toy car where you put this pencil battery, the small battery one, cell one. In the wall clock we use more than one cell, okay, two or three. So two or three cells combined together makes one battery, okay. So we have two cells here, and two cells together makes battery. So what does it does? What is the function? It generates large amount of potential difference. Means it's going to give more potential, means more electrical energy, okay. Next, open switch. This diagram symbol represents the switch is open, means the switch is not on, it's off, okay. Open switch means switch is off, it's not connected. So this symbol represents. Circuit is incomplete if the switch is open, current will not flow, no flow of current, okay. Number four, closed switch. So closed switch will represent by the symbols, same symbols with one dot in the center, okay. So this shows the circuit is complete, means the switch is on. The circuit is complete and the current flows in the circuit. A wire joint. This is the symbol which represents the wire joint. When two wires brings together, and if you are joining the wire, this symbol will represent the joint of the wire. It used to connect wires together, okay. That's the function. Number 6, we have wire crossing without joining. So this symbol represents the two wires cross one another but did not touch, okay. For example, this is one wire. Let's say an example, this is one wire, this is one wire. If the two wires cross one another, okay, but did not touch, this symbol represents, okay. Next we have electric bulb. So this is a symbol which we use in a circuit diagram which represents the electric bulb. So what is the function of electric bulb? Converts the electrical energy into light energy, okay. Number 8, we have resistance, and this symbol represents the resistance. What is the resistance? Resistance opposes the flow of current in a conductor. So function of resistance is to oppose the flow of current in a conductor, which means the resistance will, in a very simple way to understand, will oppose or will stop. Will not stop completely, but will oppose, means will, in other way we can say, stop the flow of the current in a conductor. Current will flow, but very less amount of current will flow. Okay, it will oppose the flow of electric current. So means current will not flow easily. Okay, current will not be able to flow easily in a wire. So when the current cannot flow easily in the wire, less amount of current will flow, which means large amounts of current is coming in a wire. Once it reaches the conductor resistance, the amount of current which is flowing in the conductor, once it reaches the resistance, the amount of current will be reduced, because all the current cannot flow, because it was stopped there by the resistance, it was disturbed by the resistance. So less amount of current will flow. Okay, in other way, disturb the flow of the current. So next we have number 9, variable resistance or rheostat. So variable resistance is also known as the rheostat, and it is represented by this symbol, a resistance with a straight line here, or a resistance with an arrow mark from the bottom. Okay, what is the function? Its resistance can be varied as desired, means we can increase the resistance as we desire. We can increase it or we can reduce it. Okay, so which will have an effect on the flow of the current. The current will either increase or decrease by changing the resistance of this. Okay, next we have number 10, ammeter. Ammeter is represented by this symbol, which has a positive terminal on this side and the negative terminals with a letter A at the center. Okay, so this is the symbol. So ammeter is a device which is used to measure the flow of current in a circuit. So listen carefully. Okay, ammeter is a device which is used to measure the flow of current in a circuit. Flow of current, the amount, how much it is flowing. Okay. Now voltmeter. Voltmeter and the ammeter, this galvanometer, they all have the similar diagrams with the letter here different. Ammeter has a voltmeter has a V, galvanometer has a G. Now voltmeter, it is used to measure the potential difference across the end of the conductor. So we have two ends, a straight wire, so we have two ends. Let's say this is NA, this is NB. Okay, we have 2 points. So between these 2 points, what is the potential difference in this wire, in between these 2 points? To measure that one, we have a device, a voltmeter. Okay. Next we have galvanometer. So galvanometer symbol is like this, with a G at the center, with this 2 conductors on this side. Okay, the 2 lines. Now the functions of galvanometer is, it is used to detect the current in the circuit. So ammeter, galvanometer. Ammeter to measure how much is the current flowing in the conductor in the circuit. Galvanometer to detect whether there is current or not. Okay, these 2 are different functions. Now for today we'll study all this. In the next class we'll study about the Ohm's law.
Stay home, stay safe.
Do it for self.
Do it for your family. Do it for India.
Let's break the chain of COVID-19.
हम होंगे कामयाब, जय हिंद. हम होंगे कामयाब, जय हिंद.
हम होंगे कामयाब, जय हिंद.